Now, base units have to shift a lot of air, so they have to be big and they have to move a lot. They have to be very stiff so they don't bend while they're shifting the air. They have to have exactly the right mass for the sensitivity of the drive unit and to define the low frequency roll-off of the entire system. They have to be well damped, so if they do ring at higher frequencies it gets absorbed very quickly. And they finally have to stop any sound inside the box from coming through the cone into the outside world, because that sort of thing is highly audible. So how do we achieve that? Well, here's the Rohacell solution. Rohacell is a lightly foamed material which is incredibly light. It's also quite stiff and well damped. It allows us therefore to put some very stiff skins on the outside of the thick Rohacell filling, which utilises the I-beam principle to make a lot of stiffness. Because there's a lot of internal damping, we see from these pictures that the impulses measured at the voice coil and the surround are incredibly well damped. Compare the impulses in the Rohacell, which is the nice smooth curve, with the paper, which is the one with a lot of wobbles on it. We see that the Rohacell solution really works there. If we look at an individual animated frequency now just outside the operating band, once again the Rohacell moving up and down smoothly is bending a great deal less than the equivalent paper cone at that frequency which is outside the operating band. Finally, let's have a look at the measurements of transmission loss with Rohacell. We see from this picture that the transmission loss in the Rohacell cone, with its two skins and absorbing filling, is about 10 dB better than the equivalent paper. So that's 10 dB less interfering sound coming from the inside of the box to the outside of the box.